Good morning, students. Welcome to 11th standard physics class. Students, today's topic is on gravitation, unit 6. Sky. We wonder how the sun rises in the east and sets in the west. Where there are comets or why stars twinkle. Okay. We have always wondered about the motion of stars, the moon and the planet. From Aristotle to Stephen Hawking, great minds have tried to understand the movement of celestial objects. Celestial means வான்வெளி பொருள்கள் in space and what causes their motion. Okay. The theory of gravitation was developed by Newton in the late 17th century. In 2017, the Nobel Prize in Physics was given for the detection of gravitational waves, which was theoretically predicted means proved Albert Einstein in the year 1915. Okay. Geocentric model. What is the geocentric? It is called Ptolemy model. The Ptolemy proposed this model. According to it, the earth is at the center of the universe and all celestial objects, including the sun, the moon and other planets, orbit the earth. Heliocentric model. Nicholas Copernicus proposed this model. According to it, the sun is considered to be at the center of the solar system and all planets, including the earth, orbit the sun in circular orbits. Next topic is Kepler's law. Kepler proposed 3 laws. The first law is called laws of orbits. Each planet moves around the sun in an elliptical orbit with the sun at one of the foci. Kepler's second law. This law is called laws of area. The radial vector, a line joining the sun to a planet, that is vector, sweeps equal areas in equal intervals of time. The third one, law of period. The square of the time period of revolution of a planet around the sun in its elliptical orbit is directly proportional to the cube of the semi-major axis of the ellipse. The t square directly proportional to a cube. So t squared by a cube is equal to constant. That is third law of Kepler's law. The next topic is Newton's universal law of gravitation. Newton's law of gravitation states that a particle of mass m1 attracts any other particle of mass m2 in the universe with an attractive force. The strength of this force of attraction was found to be directly proportional to the product of their masses and is inversely proportional to the square of distance between them. So F directly proportional to m1 m2 by r squared, or F force is equal to G. G is a gravitational constant. So G into m1 m2 by r square. So here G is the gravitational constant, that is value is G is equal to 6.67 into 10 power minus 11 Newton meter squared per kilogram squared. Next, Newton's inverse square law. The Newton considered the orbits of the planets as circular. For circular orbit of radius r, the centripetal acceleration towards the center is a is equal to minus v squared by r. Here v is the velocity and r the distance of the planet from the center of the orbit. The velocity in terms of r and t is v is equal to 2 pi r by t. Okay, here t is the time period of revolution of the planet. Okay, substituting this value v in this equation, a is equal to minus 2 pi r by t whole squared by r is equal to 4 by squared r by t squared. Okay, substituting the value of a from Newton's second law, F is equal to ma, where m is mass of the planet. So m is equal to minus 4 pi squared mr by t squared. From Kepler's third law, r cube by t squared is equal to k. Here k is constant. So r by t squared is equal to k by r squared. It is reverse multiplication, cross multiplication. Okay, F is equal to minus 4 pi squared mk by r squared. Here, negative sign implies that the force is attractive and its act towards the center. Okay, so the last equation F is equal to minus G capital M small m by r squared. So G is gravitational constant. So, M sun oda mass. Next topic, important feature of the law of gravitation. Okay, already we know the Newton's law of gravitation is given by F is equal to minus G m1 m2 by r square into r unit vector. So, important features of gravitational force, the variation of gravitational force with distance in. The distance between two masses increases. The strength of the force tends to decrease because of inverse dependence on r squared. Okay. The gravitational force between two particles always constitute an action-reaction pair. The torque experienced by the earth to the gravitational force of the sun is given by tau. Tau means torque is equal to d capital L by dt. Okay. Is equal to 0. So, the angular momentum of the earth is constant throughout its motion. This is true for all planets. This leads to Kepler's second law. Okay, the law of gravitational concludes that a mango that is falling down, the moon orbiting the earth are due to the same gravitational force. Okay, a hollow sphere of mass m with uniform density is equivalent to the point mass m located at its center. Now we can calculate the force of attraction between it and a point mass m kept outside it. Next topic is gravitational constant. In the law of gravitation, the value of gravitational constant G plays a very important role. The value of G explains why the gravitational force between the earth and the sun is so great while the same force between two small objects. For example, the distance between two human beings is negligible. Okay, the force experienced by a mass m which is on the surface of the earth is given by F is equal to minus gm e m by r e squares. That's all. So here the final using the value of g in this equation F is equal to minus g capital M r e squared by r. From this it's clear that the force can be calculated simply by knowing the value of g. So it is to be noted that in the above calculation g is not required here. This year Henry 1798 experimentally determined the value of gravitational constant g by using a torsion balance. He calculated the value of G to be equal to 6.75 into 10 power minus 11 Newton meter squared by kilogram squared. Okay. Using modern techniques, a more accurate value of G could be measured. The currently accepted value of G is 6.67259 into 10 minus 11 Newton meter squared by kilogram squared. The next topic is gravitational field. In the gravitational field, the force is basically due to the interaction. Interaction means attached between two particles. Depending upon the type of interaction, we can have two kinds of forces. First one contact force, second one non-contact force. Okay. What are contact force? Contact forces are the forces applied where one object is in physical contact with the other. The movement of the object is caused by the physical force exerted through the contact force between the object and the agent which exerts force. Then, what are non-contact force? Consider the case of Earth orbiting around the Sun. Though the Sun and the Earth are not physically in contact with each other, there exists an interaction between them. This is because of the fact that the Earth experiences the gravitational force of the Sun. This gravitational force is a non-contact force. Okay students, today's topic is over. Today's homework. Students, I have given you homework. Read and understand the questions and answers and then write the answers 3 or 4 times in your classwork note. After writing, send me the answers to my WhatsApp number. Thank you, students. God bless you all.